One final topic that I want to discuss, because this is something that we'll be calculating a lot in this class, is dilutions. So a big part of analytical chemistry, of at least doing the analyses themselves, is calculating dilutions of solutions. We often need to get things into the right concentration range um, for our particular analysis method. And we need to, be able to calculate how much we need to dilute something, or go the other way around. After we diluted something, how much was in the original. And so the equation that we use for this is pretty simple. It's just a matter of applying it and remembering how to use it exactly. So the equation, the way I remember it, is C1V1 equals C2V2. And let's define what these are. C is equal to concentration. And this works for any sort of units, as long as you're consistent on the units that you're using. And V stands for volume. Let's spell it right. Right. So our initial concentration and initial volume, the reason this equation works is that C1 times V1, that tells us the number of moles that are present in our solution. It could also be equal to grams depending on what units you're using. But say we're using molarity and volume, C1 times V1 gives us moles. And the number of moles has to be equal in our initial solution and our final solution. So C1V1 equals C2V2. The number of moles won't change as we do our dilution of a sample. So let's do a practical example here. So let's imagine that we have a 1 molar solution of hydrochloric acid, and we need to prepare a 0.15 molar solution of hydrochloric acid. Something like this is pretty common to encounter. And so the question that we have a let's say 100 milliliter volumetric flask. So we can make a total volume of 100 milliliters. We need to know how much of that 1 molar solution needs to go into the 100 milliliter volumetric flask to make the 0.15 molar solution. This is a very common sort of problem that we'll see and that you'll deal with in lab. Okay, so we have three things that we know and one that we don't, right? And so let's go ahead and label these. So C1 here, this is our starting concentration. C2 is our final concentration that we want. V2 is the final volume we want, and so our unknown is V1. How much of that initial concentration solution do we need to dilute? All right, so we can go ahead and plug these now into this equation. So we have 1.0 molar times V1 is equal to 0.15 molar times 100 milliliters. We could convert this to liters if we wanted to, but we'll get this in whatever units we use, and we'll probably want to measure this out in milliliters anyway. So we'll just leave it in milliliters. Okay, so then V1 is equal to 0.15 molar times 100 milliliters divided by 1 molar. Our concentrations cancel out, and we will get 0.15 times 100 divided by 1. Okay, so that will be equal to 15 milliliters. And so this is the volume we need of our 1 molar solution to put into this 100 milliliter volumetric flask. We would measure out 15 milliliters of the 1 molar solution, pour it into our volumetric flask, and then add sufficient water to get this to be diluted to 15 milliliters. Practically speaking, we'd actually add a little bit of water first and then add the acid solution, because you always add acid to water, not the other way around, because it can cause heating when you dilute acid. So you want to do it the other way around.